Today's problem is smallest window containing all characters. Difficulty is hard. So we are given two strings, S and P. S for string, P for pattern. Find the smallest substring in S consisting of all the characters, including duplicates of the string P. Return empty string in case no such substring is present. Okay. Let's see. Yeah, I think I think that'll work. If there are multiple such substrings of the same length, return the one with the least starting index, which would be the one that we find first. All right. We're just finding all the letters. Now, they don't have to be consecutive, and they don't have to be in any particular order. So this one, for example, time to practice, and we need to find T, O, C. So the shortest would be top rack, T-O-P-R-A-C. So we have a T, an O, and a C. And actually, opract would work too, but it says take the first one, so we take toprac. Now this one, we have a long string, and then we have O, Z, A. The shortest or the smallest substring would be A, P, Z, O. It has an O, a Z, and an A. Now again, note that they don't have to be in order, and this one doesn't work at all. So let's see, S length and P length are both between 1 and 10 to the 6th. S and P consist of lowercase English letters, complexity linear, auxiliary space O of 1. Wow, a lot of company tags here. Topic tags. Sliding window, hash, yes, on both of those. Dynamic programming, no, I don't really see it that way. Binary search, I don't see how that's going to help us. All right. What was I going to say? Oh, yeah, okay. Let me scoot this over. We need to walk through one of these examples. Like that, and then can we get this up here? No, it doesn't work like that. Well, what if... See, I need it at least there, and I can't drag this any further. Let's just try it like that, okay? So first of all, we're going to handle an edge case, because there really isn't anything here that says that P has to be less than or equal to, the length of P has to be less than or equal to the length of S. Now, if the pattern is longer than the string, then we're not going to match it. So, so that's what this is. If the pattern is longer than the string, can't do it. Now this, okay. I actually solved a problem like this on LeetCode. They have, the same problem, really. And I copied that code. Now that code, the letters, this one, we are guaranteed lowercase English letters. Now the other one was lowercase or uppercase. So we really, for this one, we could do it with 26 character integers. I just left it as is because I don't want to go through and do like minus lowercase a for all of these characters. There's quite a few. And this is really a more robust solution. You know, you can keep it this way. It'll handle uppercase, lowercase. So that's why that is what it is. I mean, you could use hash maps as well. I don't think that's as good, and also it violates the O of 1 auxiliary space expectation. So first thing that we do, and let's go back to this. First thing that we do is we have a now the hash pattern and hash string arrays are used to keep track of letter counts. Okay, so the first thing is with the pattern. All right, so for each character, the character has a character code, and we'll use that as an index into the array. And we'll keep track of the count of the letters in the pattern. Okay, we'll initialize some variables here. Start is initially 0. Index 0. Start index -1. Really, that's just a it's kind of like a flag. If that's still 1 or -1 at the end of all of our work here, then we didn't find the pattern in the string, so we'll return an empty string. Min length is initialized to a big number, and count is 0. We'll see how we use count. Let's see, and then we can go up here. Now, what are we missing? Oh, it's just the return on the substring. Okay, I'm gonna need a pen for this. Let me use this one. Okay, and actually, I would like to move that out of the way. Okay, for j equals 0. J equals 0. J is less than the length of the string, and j plus plus. Okay, so I'm going to try to, well, actually, let's do this one here. So we'll start here. Hash string s char at j plus plus. So now we're keeping track of character counts in the string. So we have 1 z, all right? Now, if the number of z's in the string is less than or equal to the number of z's in the pattern, we're going to increment the count. And in fact, that is the case. So we'll increment the count. The count will now be 1. Is count equal to the length of the pattern? No. Now the point of this line here is we need to open a sliding window. The first thing we need to do, we need to open a sliding window that's big enough to have all of the pattern letters in it. Okay? So count equal to p length? No. Okay? So let's go to the next letter. It's an O. Is O less than or equal to is the count of O's in our window less than or equal to the number of O's in the pattern? And the answer to that is yes. So our count is now 2. Now the count is still not up to the length of the pattern, and in fact it's not going to get to the length of the pattern until we can get an A in there, right? So we are going to have to keep iterating here. Okay, so now we've got 2 O's in the window. This doesn't help. The M doesn't help. The L doesn't help. The A is going to help. All right, so when we get to the A, then the number of A's in the window is less than or equal to the number of A's in the pattern. They're both 1, so count now goes to 3. And what that means is we have a window that has all of these characters, O, Z, and A. All right. Now, once we've done that, we try to start taking letters off the front, or we try to start taking letters off the front of the string by sliding the window over, if possible. Am I able to slide this over a little bit so we can see it? Yes. Okay. So the count is good, and now we do while hash string. S, char at start. Now, char at start, there is a Z. Is that greater than, let's see, is that greater than the pattern? Okay, yes, Z. So the first letter in the string in our window is Z. And what we want to know is that greater than the number of Z's in the pattern? Because if it is, we can take it off. Actually, it isn't. So we can't take it off. So we'll drop out of the while loop. Length of the window. The length of the window is 6. J, what is J? 0, 1, 2, 3, 4, 5. 5 minus 0 plus 1, 6. So the length is 6. And that is our new min length, 6. And our start index is start, which is, it's still 0. Okay. Now we are going back up to the top here. We're going to take the next letter. It's a Z. Okay. Is the hash string? Well, see, we don't have to look at this anymore because we have now gotten all of the pattern letters into the string. So this is always going to be true. Now we'll drop in here. We'll say hash string. S, char, at, start. Now the start is Z, and the count in the window is 2. The count in the window is 2, which is greater than the number of Z's in the pattern. Okay. So if the let's do it like this. If the count of Z's in the string, in the window, is greater than the count of Z's in the pattern, which it is, then we can take that off, right? We can decrement the count of Z's in the window, and we can move start. Actually, I should keep track of start on the bottom here. Start is now, oops, no, I need that. Start is now here. Okay. We're still in the while loop. Now, while hash string at character start, which is an O, while the count is greater than the count in the pattern, and actually the count of O's in the window is greater than the count of O's in the pattern. There are 2 O's in the window. So what that means is we can decrement the count, and we can also move up start. I think I'll erase this and move it. I'm going to erase it and move it. So it is now here. Okay. So we'll drop down out of this. What is our window now? Our window is OMLAZ. So actually the length of the window is 5. So we'll change it to 5. We'll change the min length to 5. And we're going to change the start. Start is now at index 2. Okay. Back to the top. Next letter is an A. Right? Is the number of A's in the window greater than the number of A's in the pattern? Yes, it is. Let's see, what is start? O. Okay, but see the window starts with an O. So there really isn't anything we can do about that. We have to leave the extra A in there, right? Let's go to the next character, P. That is actually irrelevant. We have one P in the window. We have no P's in the pattern. So, okay. Next character is a Z. All right. Well, we do have more Z's in the window now than in the pattern, but the start character is fine. The start character in the window is an O, and we got to leave it alone because it's the only O in the window. Okay. Now the last letter that we get to is this O. All right. Now let's try it. While hash string char at start is greater than the hash pattern. Yes, we have 2 O's. We have 2 O's. And we don't need that many. We only need 1. So we can go down here. We can decrement this, and we can move start. Actually, there's gonna be too much moving of start here, so I'm just gonna move start to here. All right, we're still in the while loop. Now, does the char at start, is it greater than the pattern, or is it not even in the pattern? And M is not in the pattern. So, so let's see, start is greater than, yes. So we can decrement it and move start. M is not in the pattern, so we can move it. L. L is not in the pattern. So again, we can move the start. Now we have an A. All right. Is the count of A's in the window greater than the start of A's in the pattern? And it is. So again, that means we can move the window to get rid of that extra A. Now the Z. Do we have too many Z's in the window? Yes. So we can move the window again to get rid of that extra Z. Now the window is here on A. Do we have too many A's in the pattern? No, we don't. So we're dropping out of the while loop. We're going to compute the length of the window, which is now 4. It's APZO 4. Min length is 4. Start index is 0, 1, 2, 3, 4, 5, 6, 7. And that's it really, except, can I scroll this up a little bit? What we're going to do now is return the substring, starting at the start index and plus the minimum length. So for a length of 4, starting at 7, so we'll return APZO. So again, the where do I want this? Something like that. So the solution for something like this is sliding window, 2 pointers, open the window until you get all the letters in the pattern in the window. And at that point, you can start trying to remove letters, slide the window in from the left that you don't need, either because they're not in the pattern at all, or they are in the pattern, but you have too many of them in the window. And so you can slide that over. Okay, so let's try and run this. We'll go here, move that, move this, and let me do a kind of a sanity check on this. All right, and then let's try it. Okay. So that's it. That's it for today. Please like the video and subscribe to the channel. It's free. I'll send you problems of the day every weekday, and we'll see you next time.